Hello and welcome back to Math 100. This is section 1.5, the last section of chapter 1. Now, this section is very strange. It's about problem solving, and problems come in all sorts of types and lengths and difficulty levels. And so what do you expect? Well, you don't have one nice formula, that one size fits all formula for all the problems in the world, right? So what we will learn is some general principles to help us as we solve all kinds of problems. And we have some strange problems, okay? But let's start thinking. So put your thinking cap, a hard thinking cap, all right? And then let's get started. I'm going to share my screen. And so get your notes, the blank notes for 1.5 ready, and make sure you take notes as you watch these videos. Okay, so let's get started on section 1.5. All right, section 1.5. The title of this section is problem. Whoops, I have been using red, so let me go ahead and use red. Problem solving process or strategies. Okay, as I said in my introductory remarks, problems come in all sorts of types and shapes. So what are, I'm going to use red here again. What are some helpful problem solving strategies? Okay. Have to memorize these, obviously. Okay, but George Polya is this famous math educator who used to teach at Princeton University, and he has written several books on problem solving. And he gave us a 4-step problem solving process. And number 1, identify the problem. Number 2, devise a strategy. Number 3, carry it out and revise if necessary. And number 4, look back, reflect, and think, interpret the answer. Now, of course, that's very general, right? And maybe I should underscore the importance of number 1, identify the problem. What is the problem? If you do not know what the problem is, you probably can't solve it. Okay, and surprisingly, that is the problem with many of the cases where we have something and we don't know what's wrong. Well, let's find and identify the specific problem so that we can solve that. And so that is an important first step. Okay, now in this section, we'll see many different types of problems. Okay, so there's no magic formula. You just have to start thinking. Be flexible, be logical, and be critical, right? And so you have to basically sometimes, think outside the box. Sometimes you have to do something else. So what do you do, right? Let me give you some specific hints and suggestions at this point. All right, so the specific thing I'm telling you, the number 1 is this: consider similar and maybe simpler problems. This is a great way to get started when you don't know how to start solving problems. Okay, so start thinking of something simpler, something easier, something maybe a smaller type of problems. Okay, and then consider equivalent problems. Maybe the problem is about, let's say, about light bulbs, but you may not even need light bulbs. You may be able to replace these objects with something like numbers or letters or symbols or something. Use approximation, estimate, start thinking, okay, what do you think the answer should be? Try alternative ideas and patterns. And by the way, this is exactly what mathematicians do when they solve difficult problems. And it's not unusual for a mathematician, for instance, to be using a certain approach to solve a problem for maybe a day or days or weeks or months or even years, and then change the strategy to try a different approach. And sometimes, problems, it takes years to solve a problem. There are well-known mathematical problems that have taken centuries to be solved. Okay. The last one, use visual aids. What are we talking about? In other words, draw pictures, visualize Okay, because many times visualization really helps us think. Okay, so the I should go back to this approximation. Sometimes it's called guesstimate, estimate, but with intelligent guess. So guesstimate is the word we sometimes use. All right, one important thing here. In the United States, typically, struggle in the math class is considered a bad thing. Now that is very local. Or in other words, I guess I should not say this specifically only about America, but especially in the American math classroom, struggle is considered a bad thing. But struggle is actually a good thing. All right. So the first thing I should tell you is just don't give up. It's okay to struggle for minutes, hours, and even days. Okay. Some problems may take a long time to solve. Maybe different approaches. And it's okay to leave the problem and do something else and come back to the problem. Okay. As you think, not a single moment that you struggle mentally is going to be wasted as you learn, as you gain, as you polish your problem solving skills. All right. So for the rest of this lesson, what I will do is to give you several completely different types of problems here. Okay. And I want you to use your flexibility, mental flexibility, and the creativity to solve these problems. Okay. You ready for this? Number one. Question number one, if 5 people meet together for the first time and everybody shakes hands, let's say this is pre-pandemic, so they shake hands, everybody shakes hands with everybody else exactly once. Get the picture here? 5 people meet together and for the first time, and they all shake hands, but only once, right? How many handshakes are occurring all together? Now, if you remember your math course, maybe you know the formula for this. There is a formula, but I am not interested in you using formulas. Let's see if you are faced with this problem and you do not know how to do that. What would be a good way to start thinking about this problem? Okay, any diagram, would it be helpful to draw diagrams? Okay, try to think. Maybe you can pause this for a moment and start thinking of a diagram to draw. Right, let's see if you can do that. Right. Well, let's say you have 5 people, right? So maybe you can have 1, 2, 3, 4, 5. You can draw 5 points. I say, all right, these people shake hands, these people shake hands, these people shake hands, these people shake hands. That's 4 handshakes for the first person, right? And then this person shakes, well, but he or she has already shaken hands with number 1. So maybe you can list them as, person 1, person 2, 3, 4, 5, and 1 and 2 and 1 and 3, you can do this. Maybe 2 and 3 have to shake hands together, 2, 4, 2, 5. 3 has already shaken hands with 1 and 2, and so on. So that's a possibility. It's a little confusing because you have to start drawing these pictures like this, and maybe it's hard to count. Okay. Is there a better picture you can draw here? Well, okay. How about 5 people like this, and maybe you can call them what A, B, C, D, E. You can even name them if you like. Aaron, Becky, Carol, D, and Evelyn, whatever, okay? A and B have to shake hands. A also has to shake hands with all of these people. So A is shaking hands with 4 people. B2 should shake hands with 4 people, but BA is already connected. So BC, BD, BE. C has already shaken hands with AB and B and A and B. So C has yet to shake hands with D and E. Now D has already shaken hands of A, B, and C. So now D has to shake hands with E. Now E has shaken hands with everybody. That looks pretty good, right? All you have to do seems like counting the number of edges. Okay, and that's a good thing to do. We'll come back to that. Keep this in mind, okay? Because this looks like a good picture. Don't you agree? Right. All right. A simpler and similar problem could be a problem. How about if you have, one person doesn't shake hands, so that's trivial, right? if you have two people, then the picture would be just like this. You only have A and B, and they only shake hands with each other. So that's once. If you have three people, then A has to shake hands with B and C. B and C shake hands. Does this, so you see what I'm doing here? Each point represents a person, and each edge represents a handshake between the two people, right? So what I'm doing is making this question into an abstract idea. What is the abstract idea? The abstract idea has to do with a picture with vertices, the points, and edges, these line segments, right? And I drew a line segment or an edge to represent the handshake between those two people, right? And if you have three people, it looks like you only need three edges to represent the three handshakes. If you have four people, and by the way, this is a great example, an illustration of a mathematical problem solving. Okay, you're trying simpler examples. Instead of 5, I'm thinking of 1, 2, 3, and 4. Of course, 1 is meaningless here because if you only have one person, this person doesn't shake anybody else's hand, so this is meaningless. Okay, but 2. If you have two people, you need one handshake between those two. If you have three people, there need to be three handshakes. And for 4, what is the answer? Well, A has to shake hands with B, C, and D. I guess I am calling this A, B, C, D in this way. B has already shaken hands of A, so B and C, B and E need to be connected. Oh, that should be a D. And then C has already shaken hands with A and B, but C has yet to shake hands with D, and then D is already down, right? So it looks like we have 1, 2, 3, 4, 5, 6. 6 handshakes are required. So that seems to give us a pattern. Right? Now, this is such a great example. The reason this is a good example is because I hope you have seen that we have represented a person with a point and a handshake with an edge, right? This is a kind of abstraction that is required or that can be effectively used in solving problems. No longer is this a problem about hands and people. This is a problem, a mathematical problem about points and edges, right? We have discovered correctly, for 2 people, you need 1 handshake. For 3 people, you need 3. For 4 people, you need 6. And how about this one here? 1, 2, 3, 4, 5. And then you have 1, 2, 3, 4, 5. 5 plus 5, it looks like 10 handshakes are required. Can you generalize this problem here? Yeah, let's try to figure this out because now we have studied this for 2, 3, 4, and 5 people, right? The way we approach this problem is always this way. We pick the first person. Okay, so maybe we should start with 5 people. Okay, let's call them A, B, C, D, and E. Okay, so A shakes hands with how many? B, C, D, and E, right? The 4 people. Why 4? Well, because A doesn't have to shake his or her own hand, right? So there are 4 other people. That's why 4. And so this number is always this total number minus 1. Okay. Now B had already shaken hands with A in the first stage of our argument, right? So B shakes hands with how many? Well, A is already taken care of. B doesn't shake his own hand. So C, D, E are left. So that's 4, and then we have 3, right? And now C with D and E. So that's 2 people that C needs to still shake hands with. And then D with only E, that's 1 person. Okay, E of course doesn't have, any more handshakes to do because he has been offered handshakes from A, B, C, and D already, right? So it looks like the answer is 4 plus 3 plus 2 plus 1, and that is exactly what we guessed here. with the shape of the pentagon and all of its all of these lines connecting, of the vertices, right? Um, so that seems to be the answer. 10 is the answer. Now, does this argument still carry with smaller numbers like 4? Yeah, see, if you have 4 people, the answer was first A has to shake hands with 3 people, and then B has to shake hands with 2 more people, and C with 1 more person. And so that's 6, and that is the number we came up with by the diagram, right? So it looks like this is the good way to answer these questions. Hopefully you are seeing the pattern and you understand how you get the answers. So in general, okay, if you have, let's say you have 6 people, then the answer should be 5 plus 4 plus 3 plus 2 plus 1, right? Because if you have 6 people, you have what we call hexagon, right? And you start connecting these things. And by the way, these lines are called the diagonals, right? And so basically what you have to do is to count all the edges, outside edges and the diagonals. Okay, how many diagonals can you put? And the answer is always going to be, if it's 6, it's going to be 5 plus 4 plus 3 plus 2 plus 1. And so we have come up with a formula, in a sense, to calculate the number of handshakes for any number n people getting together. All right, now just keep this in mind, because in section 4.3, we will study what we call combinations. And this is actually combinations of n taken 2 at a time. And there is a formula for it. And in that case, actually for 6 people, what you do is 6 times 5 divided by 2, and that's 15. For 5, it's 5 times 4 divided by 2, and that's 10. So that will give you the answer. But we don't have to have formulas, right? The point about problem solving is, not, can you recognize patterns? Can you abstract? Can you make your specific questions about people and handshakes into a more abstract model? And can you come up with a pattern? And that is the core of mathematical thinking. Okay, all right, let's go to number 2. The second question has to do with buying and selling. A woman bought a horse. She's a horse person. You probably know these people. I have certainly known many people who love horses. And so here's a horse person who bought the horse for $500, but later she sold the horse for $600. Okay. Then she decided, because she misses the horse so much, she buys the same horse back for $700, but then later sells the horse for $800. The question is, how much does she make all together? Now, what's confusing is that seems like she lost $100 in the middle part of this question, right? Because she sold it for 600 and she bought it for 700. So is the answer, well, some people could say the answer is 200, because the first set of transactions, she made 100, and second set of transactions, she made 100. That's 200. But then somebody could say, well, wait a second. Yes, $200 is what she made, but she lost 100 between 600 and 700, because she spent extra $100. So you have to subtract $100, and that's $100, right? 200 minus 100. So is the answer $100 or $200? Oh, wait, no, she started with 500 and she ended up with 800. So that's 300, right? Isn't that the case? Well, so what's the best way to think about this? Or if you think you have the right answer, how would you convince your friend that your answer is the correct answer? Is there a good way to understand this problem? Is there a good way to explain this problem? Okay, in many of these cases, what you should do is to start thinking specifically, like start with a certain amount of money in the bank. Start with a fixed amount. Okay, let's say, because we're talking about, $500, $600, $700. Let's say you start with 1,000. Okay, or woman starts with $1,000 in the account. Right now, she buys the horse, Now, $500 is spent. So now she will have $500 as a balance in her account and the horse, right? Now she sells the horse for $600. So she had $500 in her account. Now she has $600 in the as a payment for the horse. So she ends up with $1,100 and no horse. She misses a horse, so she buys it again. This time she spends $700. So now she only has $400 left in her account, but she has her horse. But later she sells it. And so this time she sells it for $800. So now, in addition to the 400, she gains $800 more, and she ends up with $1,200 without the horse. And that's it, right? So she started with 1,000 and she ends up with 1,200. So the answer happens to be at $1,200. That's how much she made, okay? And that happens to be exactly the sum of the first profit she made and the second profit she made, right? She made $100 on each of these pairs of transactions. So what happened to the $100? Okay, well, if you want to consider the loss of $100 here, because she sold the horse for 600 and bought it back herself for 700. Well, then what you can do is to calculate 300 minus 100, because from the beginning to the end, there is a gain of $300, right, in the price of the horse. Started with 500 and ended with 800. But $100 was lost as a loss in the middle. So 300 minus 100 is also 200, and that is a way to think about this. But if you are confused if your answer should be 100 or 200 or 300, this is a way to think about this problem in the correct way. Start with a fixed amount, whether it's $100,000 or 2,000 or 3,000 or whatever, because then you can follow this step by step to make your argument clear and understandable to others as well. Okay, I know these are two very different types of questions. You got to be flexible. You have to wear your thinking cap and try different approaches. All right, we have 3 more questions, which we will get to in the next clip of our video.